Hi, here in this video I will show what I would change if I would remake mathematics from the start. When you learn about mathematics, you start with counting. So you count 1, 2, 3, 4 and so on until 10, 11 and so on. And I would change the base of mathematics. So like most people are counting until 10 and then they get the new digit like this one. So you have 10 different base numbers, and then you get a new digit and count the tens until 90, and then you get a new digit for the hundreds and so on. And I think there's a better way to do this. I would suggest base 6, and there are a couple of reasons. First, in base 6 you have only 6 different numbers, and the human mind is only capable of holding about 5 or 6 different things in his mind. So it's much easier to do subtraction and addition in base 6, because you can do like the first place and then the second place and then the third place, and you only have to add up until 6, and then you get a new number. So it's much easier to add and subtract. The next thing is multiplying. I think that this is much more interesting, and a reason why we should change the system if you start from the beginning again. And this is like when you do multiplication, you have to learn the rows, like 2, the next thing is 4, then 6, then 8, 10 and so on, 12, 14. For next row it's 3, 6, 9, 12, 15, 18, 21 and so on. And mathematics is all about patterns, so most of the times you'll learn the rows until 10 times the row you're learning. So for example 10 times 2, so you learn until 20, here 30, and then you're gonna see patterns. For example, in the row 2 there is a pattern after 5 numbers, and in row 3 there's only a pattern about 10 numbers. And if you learn the rows in base 3, in base 6, it's much easier. For example, the first row is 2, so 2, then 4, and then you are at 6, so 6 you write in the base 6 as 1, 6 and 0 ones, and then you go on to 1, 6 and 2 ones to get 8, and then 1, 14, and then you are at 2, 6 and 0 ones. So you get a pattern. After 3 numbers, and that's the most difficult you get. because if you're doing the row 3, you get 3, then 6, that's 1 6 and 0 1s. Then you get 9 is 1 6 and 3 1s, and so on. So there the pattern emerges after two numbers. And now for the next row, it's the row 4, it's 4, then you get 8, it's 1 6 and 2 1s, and then you get the next number is 12, so you get 2 6 and 0 1s. Then the pattern starts again. So you get 2 4, and 3 2, and then 4 0 in base 6. So all you see here, also the patterns are emerging after 3 steps, and that's the most difficult. So okay, maybe the most difficult is like the row. You get like the 1 row, so 1 2 3 4 5, and then 1 6 and 0 1s. So there the pattern is only after 6 numbers, or if you do the row with 5, you get 5, then 1 4 2 3 3 2 4 1 and 5 0. Also here it's very easy, because here you decrease by 1 and here you increase by 1. So very easy. The next reason are fractions. In base 10, all these patterns are because 6 is a multiple of 3 and 2, and so that's the only number compared, like if you divide any number by 2 and then you count how many numbers are so if 6 is the only number that you can divide by 2, and after that each number decreasing by 1, you can also divide 6 by this number. So you can divide 6 by 2, it's 3 minus 1, you can 6 divide by 1. And that's not the case for 10. Like if you divide 10 by 2, you get 5, so you can 10 is divisible by 5, but not by 4, not by 3, then only by 2 and by 1. So you have this one is lacking, this one is lacking, so you have like 2 holes. And 6 is the only number where you can divide by each number that's smaller than 6 divided by 2. And it's very cool. So you get all these patterns. It's very easy to learn. And the next thing is rationals. Rationals are also important, and for example, rationals in base 10 like 1/3. There's no nice rational, I would say, because you get 3, 3, 3, and so on. In base 6, that's much easier because so much numbers, 6 is divisible by so much numbers compared to its size that like 1/2, it's easy. In base 6 it's like 0.3, because 0.3 plus 0.3, it's 3. 3, it's, if you add 3 and 3, it's one decimal place higher, so it's 1, 0. 1/3, it's also 0.2, and I would say these are the most important fractions. You can do it much further, 1/4 and 1/5, and you see that these are also great. 1/5 is not so nice. Yeah, so you got all these nice things. It's so much easier to learn, and one nice thing is, like, if you want to count with your hands, you have like five fingers, so you can count. In base 10 you can count until 10, because you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there is a special trick in base 6. You can count like 1 ones, 2 ones, 3 ones, 4 ones, 5 ones, and then you kill all the ones, go to the second hand and say 1, 6. And you can count 1, 6 plus 1, 7, 8, 9, 10, 11. Then you can kill all these and get 12. Then you can count 13, 14, 15, 16, 17, and then you get 18. So you can count until 36. Or in base 6 you can count until 5, 5, because you have one hand is like counting the sixth and one hand is counting the 1th. So it's also very, very natural to count until 6. Yeah, thank you very much for exploring this topic. I hope you enjoyed it. Until next time.